Chapter 22, Topic 22.3, Microorganisms Making Food and Spoiling Food. The objectives for this topic are: discuss why microorganisms themselves might be useful as food products, report the 10-year trends in foodborne illnesses, outline basic principles of using temperature to preserve food, list mechanisms other than temperature that are used to preserve food. In this topic, we're going to cover the love-hate relationship that we humans have with microbes, microbial fermentation, microbes as food, microbial involvement in foodborne diseases, preventative measures for food poisoning, and spoilage. We really do love and hate microbes. I mention microbes and you think disease. But they also produce yummy food like cheese, yogurt, bread, and so on. But microbes spoil food too. It just depends upon the type of microbe. I've tried to emphasize the benefits of your microbiome this semester so you don't try to sterilize your skin and GI tract. But microbes produce a horrible stench, as I'm sure most of you have noticed in lab, at any time you deal with large numbers of microbes. But in this section, you've learned that they help keep the environment balanced. Really, most microbes are either beneficial or neutral, neither harming nor helping humans. It's just a few that cause us grief. Oh, but the grief they cause. First, let's discuss the good guys. All of you are familiar with foods that are fermented. Enough said. What about food that is composed primarily of microbes? I don't mean yogurt. Even with the live bacterial cultures, most of yogurt is composed of modified milk proteins, carbohydrates, and lipids. Well, of course, mushrooms, which are the macroscopic species of fungi. Some of you may be familiar with adding yeast to foods as a nutritional supplement. A lot of vegans and vegetarians get their B vitamins and higher levels of proteins this way. Algae are used as food, not necessarily the kind found in this pond scum. If you've eaten sushi, you've eaten algae in the form of the seaweed wrap. Some forms of microscopic algae are being used as food supplements, much in the way that nutritional yeast is used. And they grow that kind in small ponds, so I imagine it looks an awful lot like this lovely pond. All of this helps us grow more food in a smaller space and in countries without enough arable land. On to the bad guys. Bacteria, protozoa, and viruses are involved in foodborne diseases. This graph shows that the prime offenders have decreased in occurrence from 1996 to 1998 levels to 2008. Since 2008, we've had some nasty outbreaks that have made a big splash in the news, specifically with Listeria and E. coli. But the incidence may still be down. How has this decrease been accomplished? We do all of the following. We prevent incorporation into food. We prevent survival or multiplication of the pathogens within the food. Temperature and food preservation are involved in keeping the numbers down. Radiation, and there are other forms of preservation. All of these are ways that we prevent pathogens from reaching the food supply, and we're constantly doing our best to improve on all of our methods. This figure shows how we can do several of the preceding. We do our best to prevent food items from entering the food supply with high numbers of microbes, especially high numbers of pathogenic microbes. Fruits and vegetables are washed shortly after harvest or before sale, depending upon what it is. We generally don't wash root vegetables too thoroughly because they store better dirty. Animal products are collected in such a way as to prevent contact with intestinal microbes, or they are washed thoroughly to remove intestinal matter and decrease microbial load. I'm thinking eggs. Eggs always have contact with intestinal matter, but if they're washed, that decreases the microbial load. Food preppers are trained to wash their hands and surfaces well. All this degerming just makes me happy. Foods can either be disinfected or sterilized through proper canning procedures, pasteurization, and cooking of the food, or through filtration of some items such as honey. Not much of the U.S. food supply is irradiated because people think that radiation stays in the food. Actually, it passes through and causes fewer changes than exposing it to the heat of pasteurization or cooking would. Heat will kill microbes. Cold prevents growth, which prevents the microbe from reaching infectious dose levels. Preservatives can be added to prevent microbial growth. Take a good look at the preservatives in this figure. Bet you didn't consider salt, sugar, and vinegar to be preservatives, huh? Nitrogen salts have been linked to colon cancer when eaten in large quantities. Moderation in all things, I say. The gases they use are things like nitrogen, not ethylene oxide, in case you're wondering. Remember, facultative anaerobes grow slower in the absence of oxygen than in the presence of oxygen. I'll let you read up in detail about the various methods of preserving foods, such as pasteurization, as shown in this picture. I will warn you that even if I don't cover something in detail in the recorded lecture, doesn't mean I won't ask about it on the exam. I do want to go over temperature in detail. This figure shows that temperatures favoring and inhibiting the growth of microbes in food. This is because microbes that spoil food are, remember back to the chapter that discussed growth requirements? That's right, they're mesophils. You may want to go back and review that chapter, since it figures heavily in this chapter. Lastly, I'd like to mention dehydration, also known as desiccation, which involves removing water from foods, and osmotic pressure, which involves the salt and sugar additives. By either dehydrating or adding salt and sugars to foods, the osmotic pressure of the food is increased. The insides and the surface of the food item become hypertonic solutions, so to speak. Unless the microbe is osmotolerant, it dies. Foods can either be eaten dried or in all their sugary and salty goodness, or the foods can be rehydrated or rinsed immediately before consumption or during preparation for eating. Well, that's it for this topic. Here are some reminders of what the learning objectives are. Discuss why microorganisms themselves might be useful as food products. Report the 10-year trends in foodborne illnesses. Outline the basic principles of using temperature to preserve food. List mechanisms other than temperature that are used to preserve food.